So let's look at the reaction of an alkene to produce a dialcohol. It's a two-step reaction, starting with the peroxy acid and the pi electrons in that carbon to oxygen bond swinging around to pick up the hydrogen on the far side. That causes the existing oxygen to hydrogen bond to break, and the oxygen is going to take those electrons and use them to make a new bond to the carbon, like that. Of course, that would cause an octet problem for the carbon here, so these pi electrons have to recoil back, and the molecule uses those electrons to make a new bond to the same oxygen from the other side of the alkene double bond. So we're going to form this endoperoxide in the molecule. Of course, this causes a octet problem for the oxygen, too many electrons. So the oxygen to oxygen bond, which is a very fragile bond anyway, breaks and the electrons swing round to plug in the gap left when that pi bond opens up. So we've got a concerted mechanism. All the bonds switch and break and change in a single step, so we avoid the production of a carbocation and go straight to that endoperoxide product. With a little bit of carboxylic acid is a side product as well. So that's the first step of our reaction, producing that endoperoxide. The second step of the reaction uses acidic conditions in water with those hydronium ions so that we can protonate that endoperoxide by picking up the proton. The electrons in the bond retreat back to the oxygen, and we produce that protonated endoperoxide and get some water. Now the water at this stage can act as a nucleophile, with the electrons being pulled away from the oxygen, feeling electron deficient because of that positive charge. It draws the electrons and the chemical bonds to the carbon towards it, slightly polarizing those bonds and making the carbons feel electron deficient. So it gives the endoperoxide, when protonated, electrophilic nature, and that helps with the reaction as the water acts as a nucleophile to make a new chemical bond. Now, of course, that would create an octet problem, so the existing bond has to break, sending the electrons back to the oxygen, and we produce the next step of our reaction. With the product almost there, we've got an oxonium ion on the molecule, the oxygen with a positive charge. So our last step is a molecule of water, this time acting as a base, is going to pull off that proton to balance out our product. Because the electrons then retreat back to the oxygen, and we produce a dialcohol. Note that the two alcohol attachments are on opposite sides of the plane of the ring, one sticking at the top, one sticking down into the board, into the page. This is what we call, of course, the anti-addition, and we always get that anti-addition product when we react with a peroxy acid in acidic conditions.